Welcome to The Blueprint, a guide for system administrators and cloud architects on understanding Gravwell's system architecture. We will provide an architecture overview, zooming out from configurations to the fundamental design principles of distributed data ingestion. Gravwell is built for enterprise scale, handling hundreds of terabytes per day. Scaling requires a distributed system, a team of machines working in concert beyond a single node. The distributed system philosophy is built on collaborative compute and high availability. This prevents bottlenecks and ensures no single failure halts the flow of data. The Gravwell architecture is founded on three core pillars: the web server, indexers, and ingesters. Pillar 1 is the web server, which handles control and orchestration, serving the front end, managing queries, and enforcing access control. It does not store the bulk data. Pillar 2, the indexers, are the storage workhorses. They receive data from ingesters and write it to disk. During a search, all indexers work in parallel to scan local storage and return results. Pillar 3 includes the ingesters, which handle distributed data collection. These smart agents gather raw data, wrap it with a timestamp and tag, and ship it to the indexers. The cluster topology is flexible and decoupled, allowing one ingester to feed multiple indexers, achieving massive scale and resilience. Gravwell offers extreme fault tolerance. If an indexer fails, the ingester instantly detects the loss, automatically reroutes traffic, and resumes load balancing when the indexer returns. Load balancing is based on consumption queues and indexer responsiveness, not simple round robin. This ensures that if an indexer becomes slow, the ingester sends less data to it. The universal ingest framework is data agnostic. Any data is processed into one Gravwell entry: a byte array, a timestamp, and a tag, supporting raw video, binary files, or text logs. A case study in correlation involves ingesting raw video alongside physical badge reader swipes. Correlating these disparate data types allows verification of the person swiping the badge. Network segmentation is crucial for maintaining security boundaries while achieving deep enterprise visibility. Enterprise network zones typically include a public zone with low trust, a corporate zone with medium trust, and a secure zone where the Gravwell cluster resides with high trust. Ingest relays, or federators, act as dual-homed proxies to safely verify and pass data across firewall boundaries, addressing the security risk of direct connections between DMZ and secure storage. The relay security allows for unified visibility by sitting on the network boundary. This bridges the gap, allowing correlation of logs from DMZ web servers with internal domain controllers securely. Now let's examine the storage topology, specifically the well concept, which is about matching hardware to data value. In the well architecture, an indexer is a storage orchestrator. It divides physical disks into logical wells, enabling you to define where specific data tags are stored for optimized cost and performance. For volume optimization, a syslog well uses massive, cheap hard drives for years of retention of low-volume text-based data. A PCAP well targets high-speed NVMe SSDs for maximum performance with massive volume data. The next section of this video discusses the deployment and maintenance consideration. We will now cover the specific hardware and operating system requirements for running Gravwell. This information is essential for proper system sizing and performance planning. Understanding these prerequisites ensures a smooth deployment and operation of the Gravwell cluster. Careful attention to hardware and OS compatibility will maximize system stability. This concludes the overview of Gravwell system architecture. Thank you for watching this video.